Degeneracy in transportation. Here, when m plus n minus 1 is not equal to the number of allocated cell, then the degeneracy exists. M means number of rows, n is number of columns. Allocated cells means the cells which are allocated here. In the question only the table will be given. We have to solve it using VAM. After we solve it using VAM, we will get the allocated cells. So based on that allocated cells, we will check whether the degeneracy exists. When we solve using VAM, find the total cost. In here it is 1900. It is found by when we multiply 8 into 65, then 6 into 50, then 10 into 80, then 3 into 80. We get 1900. Now to check whether degeneracy exists, first we check the number of allocated cells. Here the number of allocated cells are 1, 2, 3 and 4. So I have written 4. Then check whether m plus n minus 1 is equal to 4 or not. M is number of rows, which is 1, 2 and 3. 1, 2 and 3. 3 plus number of columns d1, d2 and d3. 3 minus 1, which gives us 5. So both are not equal, hence degeneracy exists. We should not choose the demand row and the supply column. Now that we got to know the degeneracy exists, we should make a dummy allocation. Dummy allocation is made to the least cost element. Least cost element means the element which is the least here. We have this number 3, but it is already allocated, hence it is not considered. Next we have 5. So we have selected 5 for the dummy allocation. So now the allocated cells will become 5. So now the degeneracy does not exist. Now solve the further question. Here in this table, the maximum allocated row or column is U1. As we see, other rows U2, U3 are not maximum allocated like U1, and also V1, V2, V3 are not maximum allocated like U1. Hence U1 is selected. As this is the maximum, it becomes 0. U1 becomes 0. Select only the allocated cells here, which means choose the allocated cells 8, 5, 6, 10 and 3. Now write it like U1 for 8, U1 plus V1 is equal to 8. For 5 it is U1 plus V2. For 6 it is U1 plus V3 is equal to 6. Do it for other elements also. We get these following equations. We already know that U1 is equal to 0. So hence solve it. If U1 is equal to 0, we know that U1 plus V1 is equal to 8. It is 0 plus V1 is equal to 8. So V1 is equal to 8. Next, U1 plus V2 is equal to 5. So as this is 0, U2 becomes 5. U1 plus V3 is equal to 6. This is 0, so V3 is equal to 6. Solve for U2 plus V2 is equal to 10. U2 plus V2 we got here 5, so substitute here, is equal to 10. U2 becomes, the 5 goes here, so it is 10 minus 5, which gives 5. Next, U3 plus V1 is equal to 3. U3 plus V1 we got 8, so add 8 is equal to 3. So U3 is equal to 3 minus 8 minus 5. For unallocated cells, these are unallocated cells like S2 and D1 is unallocated, S2 and D3 is unallocated, S3 and D2, S3 and D3 is unallocated. This is the formula. Now for S2 and D1 it is 15. So 15 minus, this is I, this is J. So 15 minus u2, 15 minus u2 gives, we got u2 as 5. So 15 minus 5 minus uh, j is 1. So it is v1 8 minus 8, which gives 2. Now for S2 minus D3, it is S2 minus S2 and D3, it is 12. So 12 minus U2 is 5 minus V3, it is 6 is equal to 1. S3 minus D2, 9 minus of minus 5, minus 5 is equal to 9. Then S3 D3, 10 minus 5 is 6 is equal to 9. So the transportation cost is calculated. Here we do it like we multiply 70 into 8, 50 into 6, 80 into 10, 80 into 3. Here this is not selected because it is dummy. It is dummy, so it is not selected. See here, 70 units from S1 to D1 at 8 units is equal to 70 into 8 is equal to 560, which means 70 units from S1 to D1 in 8 units, which gives us 560. Do it for all the allocated cells. The final cost we will get like 1900.